Section 3.2 is called measures of dispersion. Dispersion is just a fancy term for how spread out is this variable. This is a new characteristic of a quantitative variable that we're going to be interested in. Before, we were wondering about where is the middle of a quantitative variable, but now we are going to look at how dispersed they are. Let's look at an example. We're going to compare two groups of three families, and we're going to look at the variable number of children. So group A is going to have three families. One family is going to have one kid. These are great families I'm drawing. The other family is going to have two kids. Everybody I draw here is a kid. And the other family is going to have three children. So if we were looking at the measure of center of this number of children variable, let's say look at the mean, I'm going to get 2. That's the average number of children. Here's another group of families. So in this group of families, everybody has 2 children. So in this case, our sample mean, we're going to get a sample mean of 2. And the center of the number of children these samples have is exactly the same. They both are equal to 2. But then you could ask, well, are these groups of families exactly the same? No, certainly not. One of them has families that are all the same. They all have 2 children. And the other has variability in the number of children. If we're thinking about the variable number of children, then we could describe sample A as having more variability than sample B. So we would like a way to describe this idea of variability. So we want a whole nother type of number, a number that tells us how spread out these variables are. That is our goal. So how are we going to do that? We are going to do that by using a new type of number called the standard deviation. This is a number. It's going to answer the question, how spread out is this variable? So for example, we just looked at 2 different little data sets with the number of children. And we said both of these groups have the same sample mean of 2. But we want to quantify the idea that group A here is more spread out than group B. And it's very obvious here, group B is all the same. That is the least spread out a group of numbers could possibly be. So we want a number that presumably should be larger for group A than group B, because group A has more variability. It is more spread out than group B. And that number is going to be the standard deviation. And the standard deviation basically involves 3 different calculations in determining what it is. And the first calculation you have to do is find the distance between each data value and the mean. For looking at sample A here, the first data value is 1. So what's the difference between 1 and the mean of 2, which is going to give us -1. And then we're going to do that for each data value. So now I have the number 2. So I need to find the distance between it and the mean, but hey, look at that. It's exactly equal to the mean. So I get 0 there. And then my last data value of 3, the distance between it and the mean, which is going to be 1. I'm collecting 3 distances from the mean. That is step 1. Step 2 is going to be square them, multiply them by themselves. The reason why we're squaring them is because we're really interested in how far each data point was from the mean, which is a distance, and distances need to be positive. So because 1 was below the mean and 3 was above the mean, if we want to think about how far they were from the mean, we would like that to be a positive number. So squaring it ensures that even if the data point happened to be below the mean, once I square it, I'm going to be ensured to have a positive number to represent that distance from the mean. Oops, this should have been 0. I'm just going to leave that mistake in there. So we have three numbers that are representing the distances from the mean. So what do you think we're going to do? We're basically going to find their average, which gives us 2/3. So we are not quite done. Goal here is to find the number that we're calling the standard deviation. And now, the very last step. That's nice, right? This is the last step to find the standard deviation. Take the square root. So our standard deviation is going to be the square root of 2/3. That is the standard deviation of this data set A here. It is a measure of how variable these three numbers here are. Let's look at the square root of 2/3 as a decimal. So here's the number as it looks in my calculator. And this is too many numbers. I don't need to worry about all these digits. So let's just cut it off right here and round to the nearest thousandth. And that will give us 0.816. That is the standard deviation of this data set. If I went through those same steps for data set B, I would get my step 1 is to take the distances between all these numbers and the mean, but look, they're all equal to the mean. So those distances are all going to be 0. And then I'm going to square those distances, which will still be 0. And then I need to take the average of 3 zeros. And the standard deviation of data set B is going to be the square root of those squared distances, which is still 0. So the standard deviation of set B is 0, and that's not very surprising because how spread out are these numbers? 2, 2, 2. There is no variability there. So the standard deviation for data set B happens to be 0. But for data set A, the standard deviation is 0.816, which tells us that data set A has more variability than data set B. Which in this case, it's quite obvious. If I asked you if the numbers 1, 2, 3 were more variable than the numbers 2, 2, 2, you would probably tell me they are. Standard deviation, it's the quantitative way to compare how spread out two different groups of numbers are. So we just went through a 4-step process to get the standard deviation. And we have one formula that describes all those 4 processes to us all in one place, which is why it looks fairly involved. There's a lot of stuff going on in this formula, but it's essentially just describing those 4 steps I talked about before. And remember that this symbol right here is the capital Greek letter called sigma, and what that means is to add up. It means to add up whatever you see after sigma. Well, let's look at this. This is a data value. This x sub I here is a fancy way of saying a value of our variable. And we're going to take that value and we're going to subtract the sample mean, x bar, which is what I said was the first step to finding the standard deviation. And the subscript I here indicates that we need to do that for every single data value. If there were 4 data points, we would need to do 4 distances to the mean. And then I said that the next thing we would need to do is to square those distances. There's a squared sign up here. And then I said the next step was find the average, which you do by adding up all the things, which is what this sigma is reminding us. And usually when we find an average, we divide by the number of things we have. And this is a slight difference. We're actually dividing by the number of things we have minus 1. So you can think of this as finding a sort of average, if you want. So once we do that, then the last step we just need to do is what I said, take the square root. This formula has all of those steps that we talked about in it at once, which is why it looks a little bit complicated. And this formula is specifically for the standard deviation of our sample. If we have a sample of our population and we want to get an idea of how spread out the numbers in that sample are, then we use what's called the standard deviation. The formula for that is here, but the steps that involves are these 4 right here.